One of the questions that come up about wood is, what kind of wood is the best wood to make speaker cabinets? Now, I realize that may not sound like a woodworking question, but a lot of people like to listen to music. A lot of people like audio, okay? So we're going to take a look at it. I'm known mostly as a woodworker, but I have been a sound technician before. I have dealt with audio, so I'm at least somewhat familiar with it. I've also built speaker cabinets before. Why did I build speaker cabinets? Well, it's a whole lot cheaper to build them than it is to buy them. And if you buy quality speaker cabinets, you're talking a lot of money. Now, when we're talking about speaker cabinets, we're really talking about two different types of audio, okay? At least you and I are, all right? There may be others that are talking about other things. One is home audio. And by home audio, I mean you've got a stereo system in your living room or in your family room or maybe a den, and you listen to music there, either as background or just because you like listening to music, okay? The speakers you would have with that would probably be fairly nice speakers and fairly nice looking speakers. If you're going to build them yourself, you might cover it with hardwood veneer to make it look nice so it blends in with your furnishings. And the second category of speakers is what I'm going to call the garage band. You know, maybe you and some buddies have got a garage band and you go out and do gigs once in a while, and you need some speakers for that. Well, you certainly don't want to bring your home audio speakers out like that. Too much of a chance of them getting damaged. You would want to build a more robust, a more rugged speaker for that, and you build a more rugged cabinet for it. You know, we keep scaling that up, and we get to what rock concerts and such have, but we're talking on the small scale here for us, okay? So if you're going to build speakers for that, you're not going to build them the same way. Maybe the box will be the same, maybe the dimensions will be the same, but you're going to want to finish it differently to make it more rugged. Rather than going with, say, a walnut veneer, you're going to cover that thing with maybe naugahyde, or there's a carpet-like, a nappy carpet-like material they use for that, and I don't remember what it's called. But when I build them, what I've done is gone to my local home improvement center and bought their cheapest nappy gray carpet, and I glue that on. It actually worked pretty well. Another thing you might do with those speakers is put metal corners or plastic corners on them to help protect them from impact for those, times that come when it just happens to slip and fall. If you take a speaker, I don't care any of these materials out there, and you don't do that, you drop this maple on a corner, it's going to get damaged. Likewise, the plywood, the MDF, somewhat more. The material can only handle so much impact before it gets damaged. So those speakers would be more rugged. They'd also be designed to handle more volume, because when you're out there playing in public, you need more volume than you need in your living room, okay? So they'd probably be bigger speaker cabinets, and they'd probably use bigger speaker elements to give you a more robust sound. But other than that, speakers are speakers, okay? The sound is produced by the speaker cone, which is actually a paper cone with a little cylindrical electromagnet coming out of the back that sits inside of a fixed magnet, ceramic magnet. Electricity is passed the electromagnet, and that causes it to move back and forth within the donut of that electromagnet, or that fixed magnet, and that moves the speaker cone back and forth, which causes vibration, which we hear as sound. And that's basically how the system works. So really what is making the sound isn't the cabinet, it's the speaker element, all right? So the quality of the speaker element is going to make a lot of difference in how good a sound you're going to get. How's the speaker cabinet going to affect that? Well, in any way, it's most likely affected in a negative sense. In other words, if the speaker cabinet itself vibrates, it's going to create sound as well, but it may not be the sound you want. It may be distorted sound. It may be sound at a different frequency. It may be sound with a different characteristics than that being produced by the speaker cone. It may just be delayed a little bit by the amount of time it takes for the sound waves on the inside of the cabinet to hit the wood of the cabinet and cause it to start vibrating. So any of those are negatives. So ideally, we want the speaker cabinet itself, the box, to not vibrate. That's the ideal. Well, how do we keep it from vibrating? Well, there's a couple different things that can be done. One is the kind of material we use. A heavier material is going to have less chance of vibrating. The second thing is putting some insulation on the inside so that, just regular fiberglass band insulation as sound insulation so that the sound waves don't get to the wood. A third thing that we might do is the type of joinery we use to put it together. We don't want to screw these cabinets together. We want to glue these cabinets together, and we want to use a really tight joint. For that reason, I've done these with miter joints to get really good, solid connections, okay? So those are all factors. Now, you may have heard of a a ported bass speaker. All right, they do exist, and they're used for subwoofers, and that requires some knowledge, some technical knowledge, and some mathematical knowledge that I personally don't have. All right, how accurate are they designed? How well they're designed? I really can't answer that. I will say this, though: the lower the frequency you go, the more you can get away with that. And so that's why you see it in a bass speaker, but you won't see it, say, in a tweeter, in a high-frequency speaker. Okay? So I've built these 3 speakers, and my intent here is we're going to go through a series of tests with these speakers to see how they stand up and how well they would work for our design. Now, let's just talk about the materials a moment, okay? We've got maple, we've got plywood, and we've got MDF. I chose maple as the hardwood because I wanted to use some sort of a hardwood for one of them, because maple is it's a domestic hardwood, so it's reasonably priced. It's a very tight grain, very straight grain, so it's going to be fairly consistent as far as the wood. It's not going to have knot holes. If the board I had used had any knot holes, I would have cut them out and used portions of the board that didn't have them, but there were no knot holes to deal with. So I've got a nice clean enclosure from that sense, okay? It's a fairly hard hardwood, with a 1430, 1450. So it means it's fairly dense. And so it's going to resist vibration. Okay. The plywood I'm using is just, regular ordinary construction grade plywood. And I know there's people that say I'm wrong for doing that. I should be using something better. Well, okay. If I could get something better here where I am, I would do that. But getting something better really requires getting it shipped in. And shipping a sheet of plywood is very expensive, so I didn't bother to do that, okay? The problem with plywood, now plywood's fairly easy to work with. It's dimensionally stable, which is really good for our purposes. It attaches well, but the problem with plywood is the possibility of voids, okay? I already mentioned that. Our third material is MDF, and MDF in some circles is becoming the material of choice for making speaker enclosures, okay? A lot of the low-cost, all-in-one sound systems you buy that have speakers, the cabinets are probably made of MDF with a plastic front, all right? So the MDF is chosen because it's dimensionally stable, it's very consistent throughout, and it's fairly inexpensive. Actually, it's very inexpensive. It's less expensive than plywood is, okay? So that's why it's used. What's potentially wrong with MDF? Well, MDF will not handle well shock, like being dropped. That's, I was talking about those corners that you put on it. It doesn't hold up well to water, as I'll be showing you in a bit. So there are some disadvantages to using MDF. I mean, every material has its advantages and disadvantages. I'm not saying any of these materials is perfect, but we want to look at the difference between them. In an effort to make these speakers as close to identical as possible, I built all 3 of them at the same time, making all my cuts together. So I ripped the material down to width, went and cut into sections, and then I've mitered the corners so I can do a miter assembly. The other major thing I had to do was do a rabbet on both the front and back edges so that the front and back sides of the cover can be set into them. So I've cut up my material for all 3 speakers, the maple, the MDF, and the plywood, and now I'm getting ready to glue them together. And this is one of the easiest ways to glue a box together. I'm trying to make these as equal as possible, so I'm using the same thickness material, and I'm making them exactly the same size. And one of the things we want to be sure of in this process is I don't want to leave any gaps in any of the joints. I want to seal everything up well so that the sound has to propagate through the wood if it's going to come out, or of course out through the speaker itself. We don't want any air movement in and out of the speaker case. Now, there are some speaker designs that do have what they call a bass port or bass port, where air is allowed to come out of the speaker, but that's not what we're designing here. We're going for a much simpler design. But the main thing I'm concerned about here is consistency. I want all my speakers to come out the same except for the material being used. This is one of the easiest ways there is to make a speaker. I've got 2 strips, or to make a box of any sort, I'm sorry. I've got 2 strips of painter's tape sitting here on the workbench. And I've laid out my pieces very carefully, edge to edge, to make sure it's going to wrap around evenly. And once I get all the way around, we'll take this shut. Okay, so that gives me my square, and I'm sure it's square. And then for added security in my clamping, I'm going to go ahead and put a corner clamp all the way around it to make sure I get sufficient clamping pressure. I think whoever designed these corner clamps designed them for people with 3 hands, but I only have the standard issue 2 hands, so a little tricky to set them up. Okay, so there it is, clamped up, and we'll let that dry 24 hours, and now I got to do the same thing with the other 2. We want to look at the weight of these speakers as they're built. Now, all 3 have the same speaker element, so really all we're comparing is the weight of the wood. And the reason we're doing that is that the theory is that the heavier, the denser the wood is, then the less likely it is to be affected by the vibration of the speaker, so that the speaker enclosure itself ends up vibrating. Now, we don't want the speaker enclosure to vibrate simply because it's not tuned. It's not created in such a way as to make sure it gives us a pure sound reproduction. And so the heavier the material is, the more likely it is to give us an accurate representation of the sound, okay? So this is our maple speaker enclosure. All 3 of these enclosures were built exactly the same. And this one is 3 pounds, 0.2 ounces. Here's our plywood enclosure. It's 3 pounds, 10.4 ounces, so it's a little bit heavier than the maple was. Re-zero my scale. And this is the MDF. And it is 4 pounds, 4.4 ounces. So of the 3 of them, the MDF is clearly the heaviest, and the maple is the lightest. So what that means is that the MDF should be least affected by the vibration, or the cabinet itself should resonate the least with the vibration that the speaker is causing. So it should give us the truest sound reproduction. All right, I mentioned in the introduction that water might be an issue, especially with the MDF, and especially in a situation where we're taking our speakers out to play at a venue. You know, we got that garage band and we're going out. Maybe we're doing an outdoor event, or maybe just going in and out of the venue, you know, and it rains and our equipment gets wet. How's that going to affect it? So what I've done is I've taken samples of the wood and I placed it in water overnight. And I placed it so it was just like a ½ inch of water, and the open grain is sitting down in that water, okay? And you notice I got too many samples. I added a piece of particle board just because I had it on hand and I wanted to see what would happen by comparison. I wanted to see how that would compare to the MDF, just personal curiosity. So all of them soaked up some water, not surprising. I put the end grain down in the water, they soaked up water. I expected that. But how much water did they soak up? How much did that affect the dimensional stability of the material? And how much did it affect the strength of the material, okay? So here's our maple, and as you can see, it's here dark at this end where it soaked up the water. And the original thickness of this piece of wood was 920 thousandths. And here at this end where it soaked up the water, we're up to about 950 thousandths, okay? So that's about 30 thousandths, or about 1/32nd of an inch that it's swollen, okay? That's a considerable amount. Will it affect it? Its sound? Probably. Will it affect its longevity? Probably not, okay? As you can see, I can beat on that piece of wood and it's not going to damage it in any way, all right? If I do that enough, yeah, it probably will. Now, if I soak it enough times, it really will. Now, here's a piece of plywood. This is 1/2-inch plywood. It's not the same plywood I made the speaker out of because I was 3/4-inch plywood, but it's the same type, all right? So 1/2-inch plywood normally isn't a 1/2 inch thick. In fact, it says 493 thousandths thick, the dry part here, and the wet part is 530 thousandths thick. So we've gone actually a little more than what we got here. We're talking about, 40, 50 thousandths. So somewhere between that 32nd and 16th of an inch, it's swollen. Don't see any real damage. Again, I can take and beat on the edge of this, and it doesn't come apart. But as you can see from this this was actually some weathered plywood that was sitting outside at my mother-in-law's house. You can see it started getting destroyed along that edge from being out in the weather, and you can see the grain opening up here. So there is a risk there of that happening. Now, the particle board, like I said, I just did that for my own curiosity. So I can visibly tell that this is swollen. And if we measure it, we start off with, on the dry end, 641 thousandths of an inch thick. And here on the wet end, we are up to 720. We got over 100,000. So just about 1/8 of an inch of swelling in material that's a 1/2 inch thick. That's a huge amount of swelling. Okay, how does it affect the strength? Well, let's try beating on the edge there. Okay, see, I can get that to chip fairly easily. And I can also get it to mushroom out a little bit from hitting it. All right, so that's nowhere near as strong as the plywood was, all right? Now, here's the real one. Here's the MDF. Now, I already beat on this. The first thing I wanted to show you is that the moisture soaked all the way through this piece. This is 4 inches, and it soaked all the way through 4 inches overnight. This started off the same color as my bench top, okay? And it is considerably darker from the moisture it has absorbed. And the first time I beat on it, that edge, I split this open. Let's try the opposite edge. As you can see, it can't withstand that. Why? It's lost its structural stability. It's lost its structural strength. Now, if it dries again, it'll regain some of that, but it will never be as good as it originally was. Our material thickness went from an original 5/8 of an inch, no, 1/2 inch thick. I'm sorry, this was 1/2 inch piece of material to 690 thousandths. It's gone up by about 3/16 of an inch, a little over 3/16 of an inch in material thickness. That's a huge amount. We have lost structural stability altogether in that piece of wood by going with MDF. Now, excuse me, that's not saying that MDF might not be a good material for speakers that are used in your home. But if I was building speakers for that garage band, no, I don't think I'd pick MDF. For this test, what I want to see is if the material makes any difference in the volume level that the speaker is able to produce. Now, I really don't expect to see a difference. Nevertheless, I thought it was worth testing. Okay, what I've done is I've got a small amplifier here with a 1 kilohertz tone. This is really standard in audio for testing, is to use a 1 kilohertz tone. So I'm connecting that to the speaker, and I've got the speaker sitting on a piece of foam rubber just to cut down any vibration passing through to my workbench. Here I've got a sound level meter that measures in decibels. So what I want to see is how many decibels of sound we get out of each of them. I've set the meter here at 36 inches from the speaker, and we'll keep that consistent. So we're going to start with our first one here. This is the maple. Now it's 83.6 decibels. This is the MDF. Again, all these speakers are made to the exact same design, and the speaker element itself is exactly the same. Okay, I got 83.9 decibels here. That's a marginal increase compared to the maple, which was at 83.6. And now the plywood. Plywood is coming in a little bit lower, which is interesting, at 80.5 decibels. So we had the highest was the MDF at 83.9, then the maple at 83.6, and then the plywood was the lowest at 80.5. I would say that the reason for the plywood being lower would be most likely due to voids in the plywood. Now remember, I'm using construction-grade plywood here, but any plywood, except for marine-grade plywood, is going to have some voids in it. Now, applewood, which is what most people would probably use for speakers, would have less voids in it, and it would have more veneers. But nevertheless, worse. That's probably the thing that is causing it, is the voids within the plywood. One of the biggest challenges of this project has been coming up with a way of realistically measuring what differences we're going to get out of these speakers. Now, if I was a speaker manufacturer, I'd have a lab for this and a special sound room and microphones that cost several $1,000s and everything for doing it. I don't have that, okay? I'm trying to do something in my workshop here. And although I have worked as an audio technician before, this isn't my main area, so I really don't have the equipment. Fortunately, with modern electronics, we can find apps for just about everything. And I found an app for spectrum analysis that I've got on my phone. So I created a audio file that is done from a frequency generator that I've got on my computer. It's part of an audio editing program that I have, and it contains pure tones at 100 hertz, 200 hertz, 500 hertz, 1,000 hertz, 2,500 hertz, 5,000 hertz, and 10,000 hertz. Now, in a lab, you would go from 20 hertz to 20,000. I'm only going from 100 to 10,000, okay? That should give us a pretty good idea. And what we want to do is, what we're really looking for is we're looking for how much volume we're putting out at each of those frequencies, and we're going to compare it between the three materials. So let's give this a try. Okay, I've got to zero my program, and I'm setting the microphone on my phone here 13 inches from the speaker. Okay, and we'll start the recording, and we'll start. Okay, so we've now recorded the frequency response we got from the various different frequencies there, and I've done the same thing. This is the maple speaker. I've done the same with the other two speakers, and what we really want to do is look at a comparison of these waveforms. Now, I'm not going to make you listen to me do this 3 times. Let's go and take a look at those waveforms. So here's the graphs from the spectrum analysis placed side by side, or one above the other, labeled as to which wood they are. There's a lot of extraneous information there because as I was recording this, there's always background noise and it's picking it up. What we're looking for is the peaks at those specific frequencies. So what I've done is I've drawn a line from peak to peak, giving us a simple waveform that just shows what the highest level of each of the frequencies I'm reading is. So if we take that information and we get rid of the entire rest of the waveform, we just bring those together and place them side by side, this is what we get. And as you can see, the 3 waveforms are fairly similar, minor differences. The big thing that surprised me on this, however, was if you look at the high end of the maple, you see that the high frequency, the maple does a better job of reproducing that high frequency, or the speaker in the maple cabinet, than the other 2 do. So if you're looking for good high frequencies, you might want to choose to use maple as opposed to using MDF or plywood. Other than that, really the sound produced by the 3 was pretty similar. There are some minor differences. Now, I know a lot of people like a lot of bass. Well, from what I can see looking at these graphs, there's not a whole lot of difference in the bass reproduction that you get based on the type of material. Actually, that makes sense because low frequencies are larger waves. There's a greater time between the oscillations of the wave, and so the wood is more readily able to adapt to it, whereas the high frequencies, it would have a harder time doing that. Apparently, for some reason, maple being a fine-grained wood is able to do that better than MDF, which really doesn't have any grain, and plywood, which has cross grain. When I first started planning out this project, one of the things I considered testing for was distortion, or what some people refer to as total harmonic distortion. Now, I realized very quickly, actually, that was a mistaken idea. First of all, when we talk audio equipment, if we're talking about amplifiers and things like that, distortion is a major specification. They want to be able to reproduce the sound as purely as possible. Okay, I get it, all right? When we get down to the speaker point, speakers, by their very nature, tend to distort. The question just is how much do they distort? And some speakers, especially like subwoofers, will distort as much as 20%. Now, the funny thing about that is most people prefer some distortion in their sound. So if I was trying to say that one wood would be better than another because it's less distortion, I would be going against what people want to hear. That just really doesn't work. But then I thought about that a little further and realized that distortion is a major part of our music these days. Ever since the invention of the electric guitar, distortion has been a major influence in music. Matter of fact, everything you ever hear from electric guitar, you're not hearing a pure sine wave. You're not hearing the resonance of those strings. What you're hearing is distortion. You see, the way an electric guitar works is that pickups pick up the vibration from the strings and bring it to a series of different effect boxes. Now, there's lots of types of effects boxes out there, but all of them do one thing, and that is they create distortion. They distort the original signal. So what you hear is various different types of distortion. And that's all you ever hear from an electric guitar is distortion. Now, that's expanded out in music otherwise too. Techno, what music that is referred to as techno, has a lot of distortion. It's a lot of electronic sounds. It's not created by an acoustic instrument in any way, shape, or form. Even keyboards, originally keyboards were trying to reproduce the acoustic sounds as best they could for the quality of the electronics they had available to them at that time. Nowadays, they can reproduce that sound much better, but rarely do you hear that. You hear that as a base to which they add effects before they put out the sound. So if you're asking for a grand piano sound, you're really not getting a grand piano sound. You're getting a modified grand piano sound. So with all of this distortion going on, and actually there's a lot more to it than that, there are a total of 10 different types of distortion. And you'll often find them stacked together in music. And the louder the music is, the more distortion you're going to get. Okay? So trying to test for distortion with my limited capability here would be a joke. You need a very extensive laboratory to be able to do that. And then the numbers that you get really wouldn't mean a whole lot. So I've decided not to test for distortion. If I was just to look at these materials and what I know about the materials, I would say you'll get the most distortion out of plywood. And the type of distortion I'm referring to is the possibility of a buzz being created by where the wood adjacent to where the voids are. That's not desirable, okay? As far as the hardwood or the MDF, you probably wouldn't get any additional distortion out of them. So when you're talking about speakers, when you're building speakers, really it's what's going to give me the sound that I'm after rather than what's going to give me the lowest amount of distortion. To me, any hard wood, hard, dense, evenly grained wood is going to do that. And again, I'm saying that the maple and the MDF fit that category. Okay, so now we've looked at some various categories of these speakers, and actually it came out much closer than what I expected. Oh, there were some minor differences. We had, when I look back at my notes, we got a little better volume out of the MDF than we did the other two, and we got less volume out of the plywood. We got a difference in how they handled the water. We got a bit of a difference in the frequency response with the maple actually surprising me, and they handled the high end better than the other two materials did. So really what it boils down to is what do you want? What is it you want for the sound that you want to create? Of these three materials, I would say your worst choice for anything is the plywood. Now, having said that, if I was building speakers that I was going to use for my garage band, I'd probably stick to plywood. But I would try and get a plywood that has no voids in it. And that means buying either marine grade plywood or applewood. Again, I can't get those locally where I live, and you may not be able to get them locally where you live. You may have to drive a couple hundred miles to a larger city where you've got greater selection in what's available to you. That's what I would have to do. Or, again, I'd have to have it shipped in. Either way, we're talking a lot of expense. So that's an issue. If I was building speakers to be used in my home for my living room or my family room, a hardwood or MDF would work great. I certainly don't want to use MDF for those speakers that's going out with that garage band, simply because I'd be concerned about becoming damaged, especially water damage. But again, it all depends on what you want to produce. What is the sound you want to get? And what are you willing to spend? Because we do have a cost difference here. The maple is the most expensive, plywood less, MDF even less. So that's a factor too, as it is in any woodworking project.